Okay, so when we take a look at this graphing assignment, it's just really essential to understand where the parent functions are coming from. So for instance, when I graph these parent dots here for sine, I'm literally just graphing these, right? At 0, I graph 0. At pi over 2, which is this line, I graph 1. At pi, I'm graphing 0. At 3 pi over 2, which is this line, I graph -1, and then I come back here. For cosine, you just graph the other way around. You graph 1, 0, -1, 0, back to 1. The hardest part is making sure you know which one you're graphing. And then once you do that, it's very easy. I mean, you're just going to be shifting this to the right, pi over 4 and up 1. So it's very easy to do. I will say that I would always advise doing this information first because it helps you make the graph. So like this is A, and so the amplitude is the absolute value of 1, which would be 1. The period is the take 2 pi and divide by b. And the reason it's 2 pi is the unit circle is 0 to 2 pi. And so the 1 here just makes this period 2 pi divided by 1 or 2 pi. And then this problem just has shifts. So you would shift it right. Make sure you're saying right and not plus, because I don't know if you know that plus means right or does it mean up, right? So right pi over 4. And then the vertical shift in this problem is also up 1. So I like to put the up 1 in here. I like to put a dotted line in here, okay? And then I like to do exactly what it says. Shift this point right pi over 4, up 1. Shift this point right pi over 4, up 1. Shift this dot right pi over 4, up 1. Shift this dot right pi over 4, up 1. This one's off the graph. And so it looks like this. And then you can do the range, right? The range is 0 to 2, and always in hard brackets, meaning inclusive, because those aren't open circles or anything. And then the domain for all of these is always -infinity to infinity. And you can see this one I did very similarly. I drew the cosines and I shifted it right pi and down 2. It has very similar information. When I get to this one, all of a sudden we have a -2. And what that does is it takes my parent function dot and multiplies by -2. So since we're talking about sine, the first one doesn't move. But you see how this one's at 1? It goes to -2. The zeros don't move, but the one that's at -1 will move to +1. So this -2 creates a graph that looks like this before shifting. And it really makes sense when you think about it from the beginning of the year, right? Because what happens is if I had a parabola and I had a -2 there, remember, outside the parentheses, I changed the output to the y's. Notice the y's are now 2, and they are reflected over the x-axis, just like in the fall. Then we're going to shift everything left pi over 2, and you can see me doing that. So the amplitude is the absolute value of -2. It would always be positive. The period is still 2 pi. I went left pi over 2, and then I did not move it vertically. Coming down here and looking at this problem, you know, it's the same thing. We just compressed it by a half and moved it up 1. Very easy. Compress the dots by a half and move it up 1. And then here we have our first period change. So when you change the period, it comes from the same thing that happened in the fall, where this number has to be factored out. So when you factor that out, it reduces this thing from 2 pi to pi from division. The same thing happens with the period. 2 pi divided by b will produce 2 divided by 2, which is pi. And so what that does in terms of points is you come to the x-axis. So let me put the parent function dots back on. Parent function for sine is 0, then 1, and then 0, and then -1, and then 0. And what it does is it takes this dot and divides it by 2, which doesn't do anything. But if I divide pi over 2 by 2, I'm now going to graph that dot at pi over 4. See how it's now here? And so the next dot I have is at pi. If I divide that by 2, I'm now going to graph that dot at pi over 2. And you see how I have this dot at 3 pi over 2 divided by 2? It's now at 3 pi over 4. So I go to 3 pi over 4 and I graph that dot. So that dot is now here, that dot's there, that dot's there. It's like a slinky. It's going back into its period. And the last one at 2 pi is now at pi. So that dot is now here. So again, this one's gone. It's now here. This one is gone. It is now here. This one is gone. It is now at 3 pi over 4. And the one at 2 pi is actually back to this dot. And then it asks me to shift it. Remember, don't forget this. It asks me now to shift everything by pi. And the question is, it doesn't look like Mr. King changed it. He has those dotted, the purple dots. And the reason is if I shift this back right here, pi, it goes from pi to 0, I get the same graph back. And if you go back and look at your notes, there's a very important thing that says if you shift the same as the period, the graph is the same. And the example I've used many times is the idea of having a full moon. If you shift 28 days forward, you go from full moon to full moon. But if you shift 14 days forward, that would turn a full moon into a no moon. We call it a new moon, which would mean max to min. And that's what happens here. So if you look at this problem right here, this one, when I take out the 1/2 by division, it reciprocates and makes this 2. Remember, you divide by 1/2, canceling this, but you divide this by 1/2, reciprocates and makes it 2. Okay. And so what happens is, and I'll put the original parent function dots back on. This is cosine, so be careful. Cosine goes boop, boop, -1, 0, 1. And so the first thing I did was I multiplied by negative, which put the graph down here. So the first thing that happens is the graph actually reflects like that. I'm going to erase that because there's too many graphs. And then I changed the period by dividing the period by 1/2. So if you take 2 pi and divide by 1/2, that makes it 4 pi. So what does that do here? You got to do it on the axis. If you take 0 and divide by 1/2, it's still here. Remember, it got moved down because of the negative. But this one, look, pi over 2 divided by 1/2 is 1 pi. So that dot right there is now here. Okay. And then the next dot is this one, which is pi over 2 divided by 1/2. And if you divide pi over 2 by 1/2, you get 2 pi. So the dot that is here is now going to move all the way to here. It's actually this dot, because remember, it was there, it got multiplied, so it's now there. Okay, and that would be the graph, but I now have to shift it right pi over 2, which gets very confusing because there's no room to move it. But if you moved this dot right pi over 2, this is the only dot you can move. If I move it right pi over 2, right, it goes to right there. And you can see it. Look, we had originally a max, but we shifted. Look, this is very important to comprehend. My period is 4 pi. My shift is 2 pi. That made this minimum shift into the position of the maximum, making the max a min. And that would mean the min, there'd be a point over here that's shifting that way, which would shift a point into the max. So the green graph right here is your final graph, that one right there. Okay, and that one's a little bit advanced. You know, it might be something you see more like in pre-calc, but changing a period is definitely something you will see on our test in this class. All right, so there's a couple other ones that change a period, like this one, you divide by 1/4, which seems bad, but when you actually do the math, which you can see me doing right here, you reciprocate, and that creates a shift of pi over 2. So you just take your dots, you divide everything by 1/4, like I've been talking about, which actually stretches it way over to here, and then you shift it back pi over 2. Same thing here, it's a similar situation. So let's talk about tangent, get something a little bit newer, okay? I should say different. Tangent works off of a different set of points. So let's actually take a look at those on the unit circle. I'll just draw a little mini one right here. And so tangent here and here is 0, right? And so this is 0, pi, and then back to 2 pi. And so on the axis, I graph 0, at pi, and at 2 pi. But at pi over 2 and 3 pi over 2, it is undefined, which is an asymptote. Okay, and that is going to affect the domain. The normal domain of tangent is everything except odd pi over 2's. Okay, but this one has been shifted, so let's see what happens. So this is 1. I do not take the absolute value of that. Tangent does not have a up and down cycle, so it doesn't have an amplitude, which is the definition of the rise and fall from the midpoint. It has a stretch or compression, and if I have a 1, it doesn't have one. We'll look at one next that does have one. Okay, and then the period is actually the distance between these asymptotes, which is only pi, not 2 pi. It makes sense because you see how tangent goes from 0 to 0 in pi, and also from asymptote to asymptote in pi. So the period, instead of being 2 pi over b, it's pi over b. So it'd be pi over 1, because there's a 1 right here. There's no phase shift. This graph gets shifted up 2. So the only thing I do is I just shift the graph up here. I don't move the asymptotes in this case. And so this dot will go here. This dot will go here. This dot will go here. And then I will draw my tangents. okay? So the question now is, the range is pretty easy, negative infinity to infinity, but where did I get this domain from? So maybe you can remember back in chapter earlier in the year on rational functions that you had graphs that look like this, and then you had these curves that would go like that. And the domain, let's say this is 1, 2, 3, the domain was written as x is a real number, but x does not equal 3 because there's an asymptote there. Okay, so hopefully you can remember that. Well, that's exactly what's happening here. But here I have asymptotes more than once. In fact, there's an infinite amount. There's one over here. There's one over here, right? And those asymptotes are occurring at pi over 2s. And if you just look at the numerators, the numerator here is 1. The numerator here is 3. And the next one will be 5, 2.5. There'd be one at negative 1/2. And so you just go to chapter 8 and you do a problem on odd numbers, right? So a sequence of odd numbers would be 1, 3, 5. A1 is 1, so you put a 1 in that position. The D is 2 because they're 2 apart. You distribute, you combine like terms, and you find out that in the world of math, odd means 2n minus 1. But you don't want to leave it in because n means any number. And if I put a fraction in here, I would not get an odd number. I would get 2 times 1/2. I'd get 0, which is even. So what you do is you say, instead of saying 2n, you say 2z. Z means integer. And if you do put an integer in here, you will always get an odd number. I want you to think of your favorite integer, put it in here, and you will have an odd. 2 times that integer minus 1 is an odd number. So this says every number in the world except odd pi over 2s. So let's take a look at some other ones, and we're going to focus on those domains. So when I look at this one again, there's no vertical dilation. The period is pi. Okay, but I shift it forward pi over 2. So my asymptote goes from pi over 2 to pi. And then when you shift it, you also have to shift it down 1. You realize that I don't even have odd numbers. Like if I look at this is pi, this is 2 pi, this is 0 pi, this is every pi. And so that one's the easiest of all. The way you say every in math is in. But you don't want to say every number because that would mean like 3/4 would be okay. You want to change the n to z. Now, some people, like I said, they say z, they say instead, they'll say n pi where n is an integer. And what we're doing is we're kind of like combining this, we're kind of like putting that in there and saving a step. So that I just said everything but z pi. Okay, you could technically have had even numbers. So imagine that this happened at 0 and 2 and then 4. And that would be to do even 2, 4, 6. A1 is 2. They are 2 apart. So you distribute and they actually cancel out. And so even in math means 2 in, which would be 2z. So then the next problem we have in this one is we have a tangent that has a period change. And what happens is you just divide like we did earlier. You start with these dots. Let me put those parent dots back on there. You start with 0 and pi and 2 pi, and then you divide them by 2, just like this says divide by 2. So if I divide this by 2, it doesn't move. But if I divide this by 2, that dot now goes to pi over 2. And the one that's at 2 pi divided by 2 would go to pi. And then you don't have to shift it. Right? So the entire graph goes to right here. That this dot is at pi, this dot is at pi over 2, but then the asymptotes also get divided by 2. So the one that's at pi over 2 is now at pi over 4. And the one that is at that was at 3 pi over 2 is now at 3 pi over 4. And so let me erase this part. So the graph actually comes out looking like this, and the other ones I just put in, I extrapolated them. Again, I went from pi to pi over 2. I went from 2 pi to pi, and then I moved the asymptotes in. But when you look at these asymptotes, and then I just extrapolated and went further, right? So then I said, okay, well, that means my next asymptote would be at 5 pi over 4, and then my next point would be over there. And when you look at those are odd numbers too. Like if you look at where that is, you have 1, 3, 5, and 7. That's actually more clearly odd, but it's not pi over 2s. So you just say odd again from right here. Odd is 2n minus 1, but you don't say pi over 2s. You say pi over 4s because that's the denominator. All right, and then the last one, which is not super complicated, but it does have a more complicated domain, is to reduce the graph of tangent by a half. And the way you do that is, keep in mind on the unit circle, technically at pi over 4, we should have 1. And at 3 pi over 4, we have -1. And the 1/2 would make it go to 0.5. So I just want you to see what happened there. You can just compress it and make it look compressed. So make sure that you say that the 1/2 creates a vertical compression and draw it wider, and then you can move it left pi over 4 and down 1. But now look at what's happening here. When I look at these numbers, I have an asymptote at pi over 4. I skip 3 pi over 4, and then I go to 5 pi over 4. I skip 7 pi over 4, and then I go to 9 pi over 4. And that's every other odd. So to look at that one, every other odd would be like 1, skip 3, 5, skip 7, 9. So A1 would be 1. The distance between these values is 4. Distribute the 4, combine like terms, and you get 4n minus 3, which would, when I look at it, would become every number in the world except 3z pi, which means every other odd, as you saw, and then pi over 4s. So I just showed you that so that you would understand that in the future, there might be more difficult problems like in pre-calc or in even in calculus. On your test, you're just going to have to be responsible for every pi. Like you see here, the asymptotes are at every pi, right? Look at the green ones. They're at pi, then they're at 2 pi, and they're at 0 pi. So every pi would be z pi. Or you might have to worry about odd numbers, like if you look at these, right? We have 1/4, 3/4, 5/4, 7/4, and that gives me odd pi over 4. Or I could do something that produces evens. So try not to freak out. Here is how you do well. You draw a unit circle once a day. You make sure you know how it works. You draw graphs. You know what odd and even are. And you just honestly just be calm. I'm not going to give you a crazy one like this. I'm going to give you one more like, give you one like number 2 here. I definitely will give you one where you have to adjust the period, but it'll be more like this one with a 2 and a 2 rather than one with like a half and a 1 or something. I'm going to give you something more reasonable. But you do have to change a period, you have to be able to shift, and you have to be able to do one tangent. But when I think about a tangent, like maybe I just do something like this, and I change this to pi over 4 and make this a +1 or something. I'm not going to give you one that is as hard as number 12, but I wanted to expose you to it. I hope this helps. I hope you ask questions, and I hope you do well. It's not meant to, trick you or confuse you. I'm going to give you a very straightforward test on this.